So our next question, calculate the energies of two radiations. The first radiation is of wavelength 419 nanometers, and the second is wavelength 614 nanometers. The value of Planck's constant is 6.626 times 10 to the negative 34 joules second. Show your work. So, it's the same. So we first write E equals HV. This is for the first wavelength. And C equals lambda V. Okay? And V equals C over lambda. And E equals HC lambda. And our wave, so we just have to put in our numbers here. Okay? So Planck's constant is H. So H times C equals 3 times 10 to the 8th power, I think. I think that's right, yeah. 3 times 10 to the 8th power meters per second. We'll just say that's blue, because we don't really have to write the whole thing down, really. Okay? Times that. Red times what? Mint color? Times lambda, 419 nanometers. But we want our units to be in meters, because we always do that. So 419 nanometers equal 419 times 10 to the negative 9th power meters, because 1 nanometer is 1 times 10 to the negative 9th power. And we will just we don't really have to write it as that, because we'll just put it in the calculator right away. Okay, so that would E would equal red 6.626 times 10 to the negative 34 power times 3 times 10 to the 8th power divided by 419 and divided by 10 to the negative 9th power. So we would get 4.74415274 times 10 to the negative 19th power. And yeah, but let's just round it to the 3 significant figures, okay? 7.74 times 10 to the negative 19th power, joules. So that's our first energy. Then our second energy, I'll just delete this, erase all of that, because but these will still be the same, okay? So our lambda equals wavelength equals 614 nanometers equals 614 times 10 to the negative 9th meter. Okay, so that's our orange color. Okay. And then if we put that in the calculator, we have 6.626 times 10 to the negative 34th power times 3 times 10 to the 8th power divided by 614 divided by 10 to the negative 9th power, which we get, so our E would equal 3.2374598 times 10 to the 19th power. And if we just round that to two significant figures, we have 3.24, since that's since 7 is larger than 5. And then so we have 3.24 times 10 to the negative 19th power joules. And that would be our second energy for the wavelength 614 nanometers. Thank you.